Checking your answers when solving equations. So when we're solving level 1 equations, it's quite easy to check your answers. For example, if we have x minus 4 equals 11, so a one-step equation, we can solve for our variable, so isolate our variable, by adding 4 to both sides. So x is equal to 15. We can check this by substituting the value of x that we found back into our original equation. So 15 minus 4, yes, that is actually 11. So then that works. For longer solutions, it's imperative that we use a left side, right side t-chart. It's a valuable tool in order to check our answer. And I'll show you what that looks like through some examples. So these questions are from your leveled lesson worksheet. So you might see some familiar questions in these left side, right side checks. So for number 1, our equation is negative 2x plus 5 equals negative 7. And the answer that we should have gotten for this equation is x equals 6. So once you solve for your variable, now we need to do a left side, right side check. So this is where we separate the left side and the right side of our equation. So we start with our original equation, and the left side of my equation is negative 2x plus 5. And the right side of my equation is negative 7. So now what we want to do is we want to substitute the value of x in for our x in the left side. So negative 2 times 6. Remember this, when we have a number right in front of a letter, that means multiplication. So negative 2 times 6 plus 5. Negative 2 times 6 is negative 12, and negative 12 plus 5 is negative 7. Our goal is to get the left side to equal the right side. So that is the case for this one. So our concluding statement will be the left side equals the right side. Therefore, x equals 6. Without doing this left side, right side check, we often don't know if our answer is correct or not, especially when we're doing a quiz or an assignment or any sort of worksheet if the answers aren't there for you to check right away. So this left side, right side check gives you a tool in order to do that, so that you know that if you don't get the left side to equal the right side, you've made a mistake somewhere, whether you've made a mistake solving for your variable or whether you made a mistake in your left side, right side check. Some common mistakes would be sign errors, so not paying attention to those negative values when we're multiplying or adding or subtracting or dividing. And some other errors might be doing the wrong opposite operation when we are isolating for those variables. So those are just some common things to check for if you do find that the left side doesn't equal the right side. Let's do a few more left side, right side checks. Again, this is a question right from one of your leveled lessons. So 6p equals 36 minus 4p. And the answer for p would have been 3.6. So we're going to do that left side, right side check. So the left side of my equation is 6p. And the right side of my equation is 36 minus 4p. So now instead of p, I'm going to put 3.6 in its place. So 6 times 3.6, and I'm going to do that calculation. So 6 times 3.6 is 21.6. And on the right side, I have 36 minus 4 times my value of p, which is 3.6. When I'm doing the left side, right side check, it's important that I follow order of operations. So I have to do my multiplication first before I can subtract it from my 36. So negative 4 times 3.6 is negative 14.4. And then 36 take away 14.4 is 21.6. So again, my left side equals the right side. Therefore, in this case, it's p. So p equals 3.6. Let's pretend, for example, that when we were solving for 7x minus 3 equals 2x plus 2, instead of getting an answer of x equals 1, which is the correct answer, we got an answer of x equals 2. And I'll show you what it looks like when we do our left side, right side check. So the left side of my equation is 7x minus 3. The right side of my equation is 2x plus 2. So let's pretend I got x equals 2 as my answer. So I'm going to substitute the value of 2 in for x. So 7 times 2 minus 3. 7 times 2 is 14, and 14 minus 3 is 11. And on our right side, again, we're going to substitute the value of 2 in for x. So 2 times 2 plus 2. 2 times 2 is 4, and 4 plus 2 equals 6. So you'll notice that the left side doesn't equal the right side. So it doesn't give you that same answer. So that's where you can say, well, I've made a mistake somewhere, and then you can go back and check your solution, and you can say, oh, actually, you know what? It's actually 1. So I can redo this to see if I substitute 1 in now, will I get the left side equals the right side? So again, the left side of your equation is 7x minus 3. We're putting 1 in place of x, so 7 times 1 minus 3. 7 times 1 is 7, and 7 take away 3 is 4. And now let's do our right side. The right side of the equation is 2x plus 2. I'm substituting the value of 1 in for x. So 2 times 1 plus 2. 2 times 1 is 2, and 2 plus 2 is 4. So there we have the left side equals the right side. Therefore, x equals 1. And the last one, the left side of my equation is 7 times f plus 1. The right side of my equation is 2 times f minus 1. Instead of f, I'm going to substitute negative 1.8 in its place. So 7 times negative 1.8 plus 1. I have to follow order of operations, so I must add what's inside of my bracket first. So negative 1.8 plus 1 is negative 0.8. And 7 times negative 0.8, when I use my calculator, I get negative 5.6. For the right side, again, I want to substitute the value of negative 1.8 in for f. And I solve this using order of operations. So I have to do what's inside of the bracket first. So negative 1.8 take away 1 is negative 2.8. And 2 times negative 2.8 is negative 5.6. So the left side equals the right side, which is what I want. That makes me know that for certain I have my answer correct. So f is equal to negative 1.8. If you have any questions about the left side, right side checks, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.